Trig Identities Day 1. If you are looking for these notes and videos, they'll fall under the Chapter 14 section on my website, which deals with trigonometry. So we start with, first, if we're going to deal with trig identities, we need to know what an identity is. An identity is simply an equality relationship in mathematics. The left side of the equation equals the right side of the equation. Then it is an identity. So the simplest example is 3 equals 3. It's a simple example for an identity. And we have already talked about three trig functions: sine, cosine, and tangent. Now we will expand and look at the reciprocals of each of those, and a few other identities that we can build from our triangle. So shall I stop talking so you can write a little bit? Yes. Okay. Oh, right when I started recording. Right? Okay. All right. So we want to review what we already know about right triangle trig. In this case, our angle is called x. And if we're standing on that angle, we have the side opposite, the side adjacent, and the hypotenuse.
Yep.
So if I'm standing here, then this is the opposite side. Adjacent means next to, and adjacent is never going to be the hypotenuse. The hypotenuse is always the side opposite of the 90. All right, so now, as a review, Christian, hush up. As a review, with right triangle trig, sine is equal to what? Athena, go. Opposite over hypotenuse. Oh, I need a pen. So sine is opposite over hypotenuse. Cosine is?
Adjacent over hypotenuse.
There we go, adjacent over hypotenuse. And tangent is? Opposite over adjacent. All right, well, those are just three of the options we can have. There are three more that are the reciprocals to those, and they are called cosecant. And what I want you to know about cosecant is cosecant is 1 over the sine function. So it's 1 over sine x.
Why?
And if we're doing 1 over sine x, that means that instead of opposite over hypotenuse, that is equal to hypotenuse over opposite. You did this one? You did this. No. I don't know. All right. So, remember, stop talking. Cosecant is 1 over sine. Secant is 1 over cosine. And so on the triangle, that would be 1 over what? Hypotenuse over adjacent. Very nice. And then cotangent is 1 over tangent. Adjacent over opposite. Okay, now, a couple of things that we want to clarify. When we did tangent on a unit circle, how did we get the tangent? Sine was the y, cosine was the x, y over x. Very nice. But the y was the sine and the x was the cosine. So tangent is sine over cosine. Yes. So on a unit circle, remember that the y value, when we had a point here, the y value was the sine and the x value was the cosine. So if we're doing y over x to get tangent, that's sine over cosine. All right, well then cotangent would be what? Cosine over sine. Okay. If cosecant is 1 over sine, then what could I say sine is? 1 over what?
Cosine?
Not
Or-
cosine,
or
but
cosecant?
cosecant, yes. Very nice. So sine x is 1 over cosecant x. Cosine x is 1 over what? Secant x. And the way I remember this is the reciprocal of sine starts with a c, it does not start with the x, so it's not going to be the same letter. And the reciprocal of cosine is the one that starts with the x, so it's not the same letter when you do the reciprocal. So the reciprocal of sine is cosecant, and the reciprocal of cosine is secant. All right, take out your table.
Tired of that.
Quiet, please.
That's open.
Okay. It is still opposite over adjacent. So Nick had the question, why is it sine over cosine? Do not talk right now. So, opposite over adjacent is for tangent, right? But on the unit circle, when we had this point, we found out that the y was sine and the x was cosine. So to do tangent, we did sine over cosine, y over x. Okay? All right, so on the table, next to sine x, I don't want the SOHCAHTOA information because we already know that. What I want you to put in is that sine x is 1 over cosecant x. Sine x equals 1 over cosecant x. So your first line in the table will be this.
What's one? What's on this side?
Sine x equals
Oh,
1 over cosecant.
what erase this?
That's what I want next to sine x, 1 over cosecant x. And next to cosine x, what do I want?
Oh, 1 over the secant x.
1 over secant x.
Okay.
All right? So tangent x, I want two things. I want sine x over cosine x, but I also want you to remember that it is 1 over cotangent x. So next to tangent, we should see sine x over cosine x and 1 over cotangent x. Cosecant x, I should see 1 over sine x. Secant x, I should see 1 over cosine x. And cotangent, I want 1 over tan x and cosine x over sin x. Tangent, I want 1 over, cotangent, I want 1 over tangent, and I want cosine x over sin. These are all true identities that we can use to help us solve for anything that we're asked about with truth. Any questions on what we want on the table that is separate from your notes? We're good?
I'm ready.
Okay. So those are the first common identities. 2, 3, 4, 5, 6 set of identities. Now we're going to move on to the Pythagorean identities, which are the last 3. So do you have any questions on this page? We're about to on the next page, as I say. All right. So now the Pythagorean identities. We're back in your notes. Step away from the table.
Oh, gosh.
Draw the right triangle. Label it as it is labeled on my slide. Pythagorean identity. And label the triangle with X, Y, and Z, leave it here, and the right label. Okay, so we are going to prove 3 Pythagorean identities. Well, what is Pythagorean theorem? Good. A squared plus B squared equals C squared. We're going to use that theorem to help us figure out what these identities are equal to. All right, so if we look at my triangle, sine squared, the first thing we need to know, when you see sine squared, that means sine of theta, squared. So when you see sine squared, that means sine of theta and then squared. All right, well, what is sine of theta? If I'm standing on theta, what is sine equal to? And in this triangle, opposite is y over what? That's a y. Oh, good. Y over z squared. Okay? And what is cosine? X over z. And we want to know what that is equal to. That's what we're trying to figure out. Okay, well, let's go ahead and square this. This becomes y squared over z squared plus x squared over z squared. Very nice. So we can write this as one fraction with a z squared on the bottom and what's on the top? X squared plus y squared. And with our triangle, what is x squared plus y squared equal to?
C squared?
Z squared. X squared plus y squared is equal to z squared. So we have z squared over z squared, which is equal to what? 1. Very nice. Sine squared plus cosine squared equals 1. Yes. So it doesn't matter what the angle is, quiet please. It could say sine squared of p plus cosine squared p equals what? Equal 1. So we've just proven that identity. Anna, did you have a question?
Yeah. Why are x squared and y squared equal square? I don't understand this one.
Okay, I'm going to do. So look at this. A squared plus b squared equals c squared, right? X squared plus y squared equals z squared. Okay? All right. Quiet. Yes, did you have a question? Question. All right. Okay, so we're going to use that same type of work to let us find out what these other two identities were equal to. And we're still going to, they're still Pythagorean, they're still based on these three sides. I'm going to set it up a little bit differently this time. So tangent is equal to what over what? Look at your table.
Tangent is equal to opposite over adjacent.
On your table. What do you say on your table?
Sine 1 over cosine.
So tangent is sine over cosine. So I'm going to replace tangent squared with sine theta over cosine theta squared. All right, so now I have 1 plus sine squared theta over cosine squared theta. And if I want to add those two, what do I have to do?
You just say this.
I have to take the same base. I have to get a common denominator, which means what do I multiply this 1 by? Over. So tangent be cosine squared theta alone. It be cosine squared theta over cosine squared theta. Has to be some form of 1. We're just getting a common denominator. So I'm just multiplying 1 by cosine squared over cosine squared, so that it now has a common denominator. Hold on. So now I have cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta. Yes? They have the same denominator now, correct?
Yeah.
So I can write it as one fraction, can't I? So it'll all be over cosine squared theta. And what is on the top? Please tell me the top.
Cosine squared theta plus sine squared theta.
Very nice. Well, we just proved that identity. What's that equal to? On the top. On the top.
10.
There's a hand. Tina. Equal to 1. We just proved sine squared theta plus cosine squared theta equals 1. So now what we have on the top. Oh, okay. No, it's right there. Right up there. I can get it up there. Put it in. There it is. That's the first identity we proved.
They're all one.
Quiet, please. They're not all one. We can just replace sine squared theta plus cosine squared theta with 1. So when we got that down here, cosine squared plus sine squared, that is equal to 1. And what do we have on the bottom? Cosine squared theta. All right. Quiet, please. Look at your table. What is equal to 1 over cosine?
Secant.
That's correct. So if I have 1 over cosine squared, what will that be equal to?
Secant.
Secant squared.
Secant squared.
So, 1 plus, quiet please. That's a 1. Hush please.
Something.
No, wait. And we've just gotten there. 1 plus tan squared theta is equal to secant squared theta. Don't you will find out when we work with these identities, the basic units that you want to work with are sine and cosine. And if you can get things written in sine and cosine, then you can solve the identity in a quicker way. All right, well now we've gone through this one, and yes, it is trickier than the first one for sure, but we're going to do one that's very similar right now. Now we're going to figure out 1 plus cotangent squared theta. Do not talk in between. If you have something to say, raise your hand. What will be my first substitution? Instead of cotangent squared theta, raise your hand and tell me what I'm going to put in based on your table. Raise your hand. Raise your hand. Margaret, you're not raising your hand, but go ahead. Not cosecant, but cosine squared theta over sine squared theta. Because cotangent is equal to cosine over sine. So cotangent squared will be equal to cosine squared over sine squared. All right, so now we have 1 plus cosine squared theta over sine squared theta. Tyler, say it a little louder now.
Multiply by sine squared.
Very nice. Multiply 1 by sine squared theta over sine squared theta. And now I have sine squared theta over sine squared theta plus cosine squared theta over sine squared theta. So, Izzy, what can I do now? Here to here. So what did we do? Get from here to here? There it is. Sine squared theta plus cosine squared theta on top, and just sine squared theta on the bottom. Because they have the common denominator, we can write it as one big fraction. And Jack, what is sine squared theta plus cosine squared theta equal to? So we have 1 over sine squared theta. And Ian, on your table, what is 1 over sine equal to?
Check it out. Looks like a CSC.
That is correct. CSC, cosecant squared theta. So that's what's going to go in our blank. 1 plus cotangent squared theta is equal to cosecant squared theta. Now, go to your table and fill in those last 3 identities. All right, now you have this table of all of these identities. And we're going to use these pieces of information to help us simplify expressions and to prove that certain identities are true. So we're going to start with a nice little basic one. Is the following identity true or false? Sine u equals cosine u times tan u.
Can be true.
Yeah, we can use any symbol for angle we want. We can use u, c, beta, x's, omega. All right, let's go. Write it down first. Is the following identity true or false? And then are you over there saying is that, Sarah, what you're saying is true?
Yeah.
Why do you think it's true? Okay, let's find out. So remember, here's where you write yourself your little note. The basic units to work with are sines and cosines. if you can rewrite in sines and cosines, it might make it easier to see what's going on. So if I have sine u, well, that's already in sine, equals cosine u, that's already in cosine, times tangent. How can I write tangent in terms of sine and cosine? Sine u over cosine u. And then what happens to my cosine?
It goes away.
They cancel, and so sine u on the left equals sine u on the right.
It's like, could you also talk about that cosine, when you get sine over cosine on the other side, which equals tangent?
Yes. Yep. So she,
Please don't do
so
that.
what Bella recognized is that, the tangent is sine over cosine, and if she divided this cosine over, she would have sine over cosine. So that would be tangent equals tangent. She certainly can, but there are times when keeping it in tangent will make life a little harder. Not on this one. On this one, it's fine. All right, before I move on, I want to also remind you that if sine squared x plus cosine squared x equals 1, sometimes it might be useful to do the algebra, just like Bella was just saying. And we might have a sine squared in our equation. Well, what is sine squared equal to? Do the algebra, get sine squared by itself. What would it be? 1 over, not over,
Negative
minus cosine squared. It's just using algebra to rearrange the equation. Okay, and then cosine squared theta would be what? Or cosine squared x would be 1 minus sine squared. And we had 1 plus tangent squared equals secant squared. So somebody raise a hand and give me another equation I could use based off of that.
You don't need to talk.
Right, there's your tangent squared.
So I could say tangent squared equals. So for tangent in this equation, what would it be, Bella? Just let her go. She knows what she's doing.
Wait, what am I solving for?
So it's solving for this tangent squared in this equation. So you would subtract
The one.
the 1. So you get secant squared x minus 1. Okay? And what would 1 be equal to in that equation? So if I wanted to get 1 isolated, that means I need to move the tangent square, so it's equal to what? Minus?
Yes.
And, yeah, and for x. It's just simple algebra, moving things across the equal sign. So once we have the basic Pythagorean identity, we can rearrange it a little bit when we need to solve for any missing parts that come up in the problem. Okay? All right, questions on this page? Okay, don't worry, we do this for a few days so that we get good at it. So now, we're going to simplify the expression to a single trigonometric function. So that means I just want 1 sine, or 1 cosine, or 1 secant. Now, so give yourself a direction, simplify, and write down the problem, please. Keep your table right next to you. All right, we're simplifying 1 minus cosine squared times cosecant x. Okay, what is 1 minus cosine squared equal to?
1 minus.
Look at sine squared plus cosine squared equals 1. And if I do 1, I subtract the cosine squared, we get sine squared x equals 1 minus cosine squared x. So that means I can replace this 1 minus cosine squared x with sine squared x. Okay, I still have 2 different trig identities. This one's already down to sine. How can I rewrite cosecant x? Very nice. So we get sine squared x times 1 over sine x. And what will that equal?
It will be
Just
Very nice. Sine x. Because sine squared x means sine of x squared times 1 over sine x. So that's canceling top and bottom, right? So that one goes away, and that goes to the first, and we're left with sine x. One trig function.
What about the one? Where's the one? So it's multiplying by
It's sine x times 1 is sine x. So we don't have, you could write it still times 1, but that's still just
No, because you're getting the right? Like the top one,
This?
is one line.
Okay, quiet please.
I kind of don't know.
Hush. So 1 minus cosine squared, we went back to our sine squared plus cosine squared equals 1. And if we do 1 minus cosine squared, that's equal to sine squared. So that's where that goes. Other questions on this one? China question? All right, so now we'll get better at seeing what we can do on the top. We're simplifying 1 minus cosine squared x over secant squared x minus 1. So when I see those, I know that I am going to be using this one, sine squared plus cosine squared x equals 1, and 1 plus tan squared x equals secant squared x. Those are the two factoring identities that I can use and rearrange to do my substitution. Okay, so secant, what can I replace the top with? 1 minus cosine squared would leave me with, there it is, top is sine squared x. Excellent. All right, Paul, the bottom, what is it? Very nice. Secant squared x minus 1 would leave me with a tan squared x. All right, well, you do want to try and get to one trig identity as possible, or simplify it as far as you can. I know I can rewrite tangent as sine over cosine, correct?
Yeah.
So now we have sine squared x on top over, how do I write tan squared? And it'll be sine squared x over cosine squared x. When we divide by a fraction, we do copy dot flip, so we'll copy the sine squared x, dot, and I flip the bottom, so we get cosine squared x over sine squared x, and what happens? Yep, we get some canceling. And then we have cosine squared x, and you're done there. You're back to basic units of cosine. There's nothing I can do to change that to make it look nicer. There's our answer. So these are like little puzzles that you have to figure out what do I substitute in to change how this thing looks. Any questions on this page? All right, moving on. Okay, so when you see one that looks like this, I see a cosine squared in the first term and a cosine squared in the second term. And the idea then, what I can do to change the appearance.
Yes.
What?
You have to simplify tan squared x first.
Oh, that's not a bad idea at all.
Oh, yeah.
Yeah. You are. All right. So we've got cosine squared x plus cosine squared x times what? CJ?
Sin x
Sine squared x
times,
over?
over cosine.
Yeah. How does that help us?
Because you can cancel
That one and that one. What does it leave me with?
cosine squared x times
Plus
sin.
sine squared x. And what's that equal?
That equals 1.
Yes, it is. So this one simplifies to 1. The other thing that you could have done is, when you see this, something to keep in mind is that we know how to factor. I can factor a cosine squared x out of each of those, leaving me with 1 plus tan squared x. And we know from our Pythagorean identities that 1 plus tan squared x is equal to secant squared x. And secant squared x is 1 over cosine squared. Now, CJ is definitely quicker, but I do want you to remember that factoring sometimes can get us to a form that we recognize a little bit. Okay? Questions there? Okay. All right. So, simplify this expression into an expression whose only trig function is sine x. So we want all in terms of sine. All right, well, we already have sine to the fourth x, so that's fine. What we need to realize is that cosine to the fourth x means cosine of x to the fourth, which is the same as cosine squared x to what power? Squared. Right. And what can I replace cosine squared with?
1
You
minus
want sine, yes, here we go, 1 minus sine squared x, because we could bring in secant, but we want to be, they told us we have to have sine. So cosine squared would be 1 minus, 1 minus sine squared. So now when I come back over here, I've got sine to the fourth x minus, I'm going to replace cosine squared with 1 minus sine squared, and then squared. That's it. The only trig identity or trig function we have there is sine. Now, there are multiple ways to get to the endpoint with trig identities. The person next to you may do it a completely different way and it's still correct. Okay, some ways are shorter than others, but there are multiple correct answers. All right. Our last one. So we just did a whole chapter on rational expressions.
Copy that for
Yes, I would copy that flip on this. So I'm going to have sine theta over cosine theta plus cosine theta over sine theta. And dot sine theta over 1.
Did you cancel inside?
We will be able to cancel some, yep, but we need to distribute this sine theta to both of our fractions. So when we multiply by the first fraction, we get sine squared theta over cosine theta. The second one does have a nice cancel that happens. That leaves me with what? Careful, the signs cancel. Just cosine theta. Okay. Now to be able to add these, I need a common denominator. So I multiply cosine theta by what? Minus cosine theta over cosine theta. Good. And I'll multiply by 1. So now I have sine squared theta over cosine theta plus what? Cosine squared theta over cosine theta. I'll hold off a second.
1.
Where's the 1? Where's the 1? No, only the top, correct, Alex? Only the top equals 1. So this is sine squared theta plus cosine squared theta all over cosine theta. And sine squared plus cosine squared is 1. So we have 1 over cosine, which is equal to? Secant theta. They're very important. All right, that's our last one. So your homework is the worksheet that you have in front of you, and we're going to do, I will say we're going to do odds for homework, and then when we come to class tomorrow, we're going to do the evens before I check the paper. Okay? The odds will be done tonight. Okay? So you're doing 1 through 13 odds. Use your table to help you, and we'll go over it in class tomorrow. We stay on this topic for the rest of this week. Okay? We can put it in. All right. Any questions on what we had here? The video will be posted after lunch. Okay? On the homework? On the homework? All right, well, let's do it. I'll keep videoing. What's number 1?
Theta, sine theta.
Okay, and we're asked to simplify, right? That's what Jackson say?
Yes.
Okay, so sine theta is already in its basic unit. Secant theta we can change to what? 1 over cosine theta times sine theta. Well, sine theta is sine theta over 1. So on the top we have sine theta, and on the bottom we have cosine theta, which is what? Tan theta. Right. I'm happy to do a few more. We're not out till 30 yet, I don't think. What? What was it, 40? Oh, let's keep going. What's number 30? Go ahead, Jeff. And squared theta minus secant squared theta. That's it? That's it? Yes, okay. All right. So when I see tan squared and secant squared, what identity do you guys think you're going to use? I see those squares. Pythagorean. Okay, you're Pythagorean. The Pythagorean identity with tans and secants is what? 1 plus?
Tan squared x equals secant squared x.
Okay. Well, I see a secant squared right there. What does that equal to?
1 plus tan.
1 plus tan squared. So we're going to replace that secant squared. So we have the tan squared in front minus 1 plus tan squared. Which is going to be tan squared theta minus 1 minus tan squared theta. What happens? Tan squares are gone. We're left with minus 1 negative 1. Athena? You certainly could have gone to sines and cosines. On this one, you could have said sine squared over cosine squared minus 1 over cosine squared and then combine the fractions. But I think the Pythagorean go over there. Shall we move to 5? Amber, read 5, can we see?
1 minus cosine theta and 1 plus cosine theta.
All right. This one is already in basic units. All it has is cosine. Any ideas on what we should do? We can't, because it's not 1 minus cosine squared. No, foil. Yeah, foil this thing. When we foil it, we get 1 on the outside. Sorry, the first gives us 1. Outer is going to give us plus cosine theta. Inner is going to give us minus cosine theta. That's lovely. And last will give us minus cosine squared theta. So those middle terms cancel.
1 minus cosine theta.
Which is just
And what is 1 minus cosine squared theta equal to?
sine squared.
Very nice, sine squared theta. There's our answer. So our algebra skills on the board today will be helpful. All right. The answer is right there. Just 9 squared theta. Yeah. So I'll stop here. You guys do some and we'll pick up tomorrow. I'll do them on the board if you want to come up.